Are your prints failing or coming out looking less than perfect? The secret might be in your printer's calibration. Hi, I'm Erica with LNL 3D Solutions, and in today's video, I'll guide you through the essential calibration steps for your LNL FDM 3D printer to ensure consistently high-quality prints. Let's get started. First, we start with bed leveling. This step ensures that the nozzle maintains a consistent distance from the print bed across its entire surface. Use the bed leveling knobs to adjust the corners of your print bed. Slide a piece of paper between the nozzle and the bed. It should drag slightly when you move it. If your printer has an auto leveling sensor, in this case a Euclid probe, we will initiate the leveling procedure using the clipper pad. Go to Configuration, Bed Leveling, and while our nozzle and bed are at print temperature and our probe is on, we'll tap Screws Tilt. It will then probe each corner and tell you how many degrees to adjust your bed leveling knobs, clockwise or counterclockwise. With our bed locking kit, each click you hear when adjusting is 2 degrees. The Z offset determines the nozzle's starting distance from the bed. For most filaments, you want the nozzle to slightly squish the first layer onto the bed. Make sure the probe is off. Then from the clipper pad, we'll tap Configuration, Z Calibrate, Start, and End Stop. From here, take a piece of paper and place it between the nozzle and the bed, and slightly lower the nozzle until the piece of paper drags slightly when you move it. Then tap Accept, and Clipper will reboot. Now, using the probe, we will level the bed once more and then run a bed mesh. To run a bed mesh, go to Configuration, Bed Mesh, and then Calibrate. Once it's done, tap Accept, and Clipper will reboot. Revisit bed leveling and Z offset regularly, especially after moving your printer or making hardware changes. Next, let's ensure your extruder delivers the right amount of filament. First, make sure the nozzle and bed are at print temperature. When we calculate E-steps or extruder rotation distance, we want to do so in an ideal situation as possible. So if we can, we want dry filament, and we want to purge out any extra material that still might be in our hot end. Make sure we have a good amount of tension based on our material. Once that's finished, we'll want to run an extrude. First, do 25 millimeters at 5 millimeters a second, then tap Extrude. We want to make sure we're getting a nice clean extrusion, no filament going off to the sides or any clogs. Now take a dry erase marker and a ruler and measure 100 millimeters of filament. This ruler has a bit of an offset, which is good for our test. So we'll go ahead and mark it at 10 centimeters. Now in Mainsail, in the extruder section, we're going to set filament length to 100 millimeters and hit Enter. And we want to set our extrusion feed rate to 1 millimeter per second. Hit Enter, then click Extrude. It will take some time, but we'll let it extrude until it stops. When it's done, we'll take the ruler again and measure the position of the mark on the filament. In this case, it looks like it over-extruded by 1 to 2 millimeters, since we measured it right at the 10 centimeters. And now it's a little bit lower than the offset line. It's good to have a ruler with a little bit of an offset for measuring, so if it over-extrudes, you can kind of get an idea of how much it over-extruded by. So we'll say this over-extruded by 2 millimeters. So now, back on Mainsail, we'll go to Machine, then Printer.cfg, and since we are testing our extruder rotation distance on our first extruder, we'll go to Extruder Editable, under the extruder, find rotation distance. We're going to take our rotation distance, copy it, and paste that number into a rotation distance calculator for Clipper. And under Requested Extrude Distance, we'll type 100 millimeters. And under Actual Extrude Distance, we'll type 102. And then click Calculate. Now we'll copy our new rotation distance and going back to mainsail in our printer.cfg, we'll replace the old rotation distance with the new one. Then hit save and restart. Write down your E-step values and keep them handy in case of firmware updates or resets. Now let's calibrate the X, Y, and Z axes to ensure smooth movement and accurate dimensions. Use a ruler or straight edge to confirm the gantry is level on both sides. If not, you may need to tighten or loosen the gantry screws underneath the printer to realign it. Belts should be taut but not overly tight. Loose belts can cause layer shifts, while overly tight belts can strain the motor. Regularly check the lubrication of your rods and bearings to keep axis movement smooth. Before you check flow rate, make sure you make all your rotation distance adjustments before you start this step. In your slicer, in this case Orca slicer, we'll go to calibration, flow rate, and the recommended YOLO. You'll then see 11 test prints with different flow rate values. We'll slice this plate and print it. Examine the finished blocks and determine which has the smoothest top surface. After choosing the best value, positive or negative, in our slicer, we'll go to the Edit Filament Preset tab, scroll down to Flow Rate and Pressure Advance. And under Flow Rate, this is where we will adjust our value. For example, if our flow rate was 0.95 and we determined the smoothest top surface was 0.03, we would adjust the value from 0.95 to 0.98. After we're done, we'll then save the preset and close the window. Print a temperature tower to find the optimal temperature for your filament. Look for layers with smooth finishes and good adhesion. Keep a log of your ideal temperature settings for different brands and types. And that's it. With these calibration steps, you'll significantly improve your print quality and avoid common issues.